Hey everyone, thank you very much for joining us today in this very special NGINX live stream when we're going to talk about Kubernetes, the how, the why, the where, the what's next. My name is Dor Zakai. I run the solution engineering team of NGINX, also known as the NGINX Ninjas here in EMEA. And with me, I have a very good friend of mine who is the technology evangelist and lead around the cloud and Kubernetes technologies from VMware, Oren Penso. Oren, do you want to do a proper introduction to yourself? I know I read out like a big old title over there, but you deserve that.
That's fine. I'm Owen Penso. I'm a technical leader for emerging technologies in VMware for the last 4 years. I'm doing cloud native, Kubernetes, containers, and everything else.
So Oren, thank you very much for joining me today. I gotta say that this is a bit of a different theme for us, right? We've been working together for I don't know, probably more than a decade on different projects, different products, to be honest, did a lot around cloud. Both of us are coming from interesting background from, FSIs to different government project and so on. So we can share a lot of knowledge and a lot of expertise, I would call it. But to be honest, I want to share the blood, sweat, and tears from what we're seeing and what we've been basically preaching for the past, I don't know, past couple of years when we started to talk about cloud. You and I are both CrossFit fanatics, so I was thinking at the beginning to maybe do it as some type of an EMOM. For those of you who are not crazy as we are, is EMOM is every minute on the minute and kind of do a spitballing of different questions. But I guess we're gonna be too excited of that, and nobody wants to do a burpee in the middle of a live stream. So maybe we'll do it in a different way. So Owen, as we go into Kubernetes, I think the number one question, and I'm a big preacher of keeping everything Sesame Street simple, right? If it's not simple enough, if you cannot explain that to my grandmother, then we're probably doing something wrong. So maybe for the sake of it, what exactly is Kubernetes? Because we talked about it. These are things that we've seen probably more than a decade ago, but it was probably in a different name or different form. So give me your stuff. What do you see?
Yeah, well, that's a great question. What is Kubernetes? And basically, to answer that question, we need to roll the cage back like 5, 6, 7 years back to understand why containers, right? Because eventually, Kubernetes is an orchestration layer, it's a management layer, it's an API platform to manage workloads. But those workloads are unique, right? Those are containers. We are not managing with Kubernetes anything else yet, and we can get into that further down the conversation. But it was made for containers. And to get to the bottom of why containers, we need to get into the landscape of the business competition out there right now. Every business wants to be the first one to, you know, just give new features to his customers, get out with products as fast as you can, and just get that competitive advantage against everybody else on the market. That business initiative or business drive basically changed the way that we are developing software. And I'm not talking about containers. That's exactly the point. The technology revolution we are seeing in the last 6 or 7 years or 8 years and now is being driven by the application side, by the architecture of the application, the way that we are developing software. And we can take that like 20 years back and equivalent that into the transition between physical servers and virtual machines. We had different applications, smaller applications that we just didn't want to waste a physical server on, right? And we've created just small virtual servers to consume better the physical hardware. Now, in the last transition of the application landscape, we just got that application even smaller. How small? 60 lines of code, 50 lines of code, something which is really like siloed, specific component inside your application. Now, that 60 line of code can't be facilitated by a VM because it doesn't make sense, right? Exactly like we've divided the physical server to VMs. Now we need something else to take that 60 lines of code and basically support that in the infrastructure.
And you know what you're saying is actually very interesting because obviously we've been working together, as I said, for a while now, right? And one of the biggest challenges we saw with all of our customers. It doesn't matter what vertical, it doesn't matter the industry. They all kind of came to us and said, hey, listen, we got to go out there. We got to be out in the market. And I got to call it out, right? The whole thing that happened with COVID, right? The whole COVID related businesses, the tool sprawl, everything that goes around that. A lot of people said, hey, listen, we're losing our market share. We got to get something out to the market. And a lot of the companies out there, and it doesn't matter if they're young or legacy customers, legacy apps, whatever, right? It's they all started in a very big process, huge applications. You see updates every once in a blue moon, and this the name of it is, it used to be the monolithic apps, right? That big application with that one, I'll call it data source just for the sake of things to make it easier, right? Where you have the developers, where they go in, they make the changes, they publish them, it goes through the different verification processes just to see that everything is okay, and then you push it to the customers. I'm not even saying to the cloud. The biggest challenge we saw with that is that if it's a banking app, right, or if it's some kind of a media app or even a shopping app, right? First of all, you don't want to harm and you don't want to cause any fault to the user experience. Second, you don't want to spend the time of actually getting the app up live there. But again, the other problem is, how are you supposed to push those minor updates without going through this whole process? So we're hearing a lot in the industry. You hear a lot of, oh, yeah, we're a big company and we want to move from the monolithic to microservices. And I think we saw a lot of it going on, especially during COVID, right? I think this kind of give it a little bit of a turbocharge around the different ways of people developing apps. So what do you see about that? What's your view on the whole transition from monolithic to microservices without yet talking about who moved my cheese, right? So let's hear it from you.
Yeah, so that's exactly what I've said about like the speed of getting idea to production, right? Is how fast can I take my idea of some kind of competition on the business side and push that as an application feature into my app in production. And when you talk about like monolithic apps, there's a lot of different components and a lot of different development teams in that. So when you want to change one component, everybody needs to gather around and upgrade the entire monolithic application. So if you remember, like 10 years ago, or even more than that, we've divided the monolith into three layers, right? The three layers app, the front end, app, and database, right? And the back end. And those three layers or those three parts of the application are still a monolithic app. Because if you want to change in your front end, in your web page, you just want to change the search bar to make some kind of adjustment, to use some kind of AI or ML or something like that in that search bar. You need to change the entire web page. So that's why we need to take that specific search bar and divide that into a microservice or a cloud native architecture where you have just that. Now, in an application side of things, and I don't think like that's the talk to get into that, but if you want to check it out, you can check the 21 factors of the microservice. If you want to develop something that is a microservice, it should be siloed, right? It should be a standalone. The way that you're consuming it should be always the same, no matter what's going on inside the code. So there's specific way to develop that and to modernize your application from that monolithic application to microservices and cloud native application. That's the first thing. Now when you ask people in that landscape, in the cloud native landscape, let's say the founders of Kubernetes, what is the first thing that the application should do? They will tell you that the first thing is one factor. Your application should be restarted without any effect. Because if the application can be restarted, you can't use the power of containers. And we haven't got into that, containers, Kubernetes side of things. But when you have that application that can be restarted, then you don't care about that component. If it's a stateless app and it can be restarted, you can now kill that container or kill that specific app and just create a new one.
So right now what you're saying is very interesting, because you're actually getting into the point of services, right? Where you say you've got an app, and rather than change the whole app or restart the whole app or reopen, or let's take it in, again, layman terms, Sesame Street simple, right? If an app breaks on all of us, on our phones, for example, right? What's the first thing you do? You either long press, push, whatever you do, swipe up, hit the X button or whatever, you kill the app and you restart it again. So what you're saying basically is one of the beautiful things about microservices is if something breaks or if we're doing some type of an update in the background, if it has nothing to do with what the user sees right now, and let's call it the foreground in front of him, he's not using, then you're saying it shouldn't really affect the user. Is that the way? Is that the process of what we're seeing right now?
That's one of the key value proposition of that architecture, because it's a cats, it's a cattle's versus pets, right? We like, you can take that, behind that service there's that, you can have like 10 different microservices doing exactly the same thing, same web page, same front end. Now you know that a load balancer is basically dividing the traffic, right? If one of those will be killed, nothing will happen. The traffic will be diverted into 9 others. The question is, or the value is, what can just spin up a new one to bring you back into that 10 microservices that you wanted to be in, like the state that you wanted to be in. And that's exactly where Kubernetes is getting into that, playground. Kubernetes allows you to create a declarative way for your application to run, and it will always control that intended state against the run state. So if you said, I have a front-end service, and behind that front-end service, I have 10 microservices, 10 containers that does exactly the same thing, exactly the same front-end web server, and one of them is dead because of no matter what, Kubernetes will say, just a second, I have 9 containers, I should have 10. Okay, let's create a new one. Now, think about what I've said about the first factor, or the one factor. If the application can restart itself without affecting anything else, that one container should affect something, would have affect something, right? So that way of development is also the way that you can, then propagate that value back into the infrastructure. And that's the most important part. The most important part is the application drives the infrastructure in the last 6-7 years. It's not the opposite. If you think about it, and we've talked about like 20 years ago, then the infrastructure drives the application. So the change to VMs was because of the infrastructure. We want to consume the resources better, so we divided the physical server into virtual machines. That was the infrastructure evolution, not the application evolution. Now it's the application side.
So you're saying something really interesting here, because I was kind of waiting for the right time to position this and kind of spin it back to where are we going from this, and why Kubernetes, why containers, all of those things. The VM story is actually a great one, because I think everyone within our industry, or the software industry, is pretty much very well aware of, okay, what is a virtual machine? Why exactly do you need this? Why? And we all need to remember, and we need to hit pause on this for a second, right? The whole transition and the move to virtual, people at the beginning said, yeah, that doesn't make any sense. Why would I do something virtual? It's, again, this whole who moved my cheese approach. And it's great to talk about it after such and such years in the industry and say, hey, we've seen it before, right? But the thing about this is, with VMs, the value was actually to have one full-on strong, muscle car type of a computer, where you run multiple different OSs, multiple different of application in our perspective. And then if, God forbid, something happened to one of the others, it kind of, and this is where we're bringing in, it's kind of containerized to the rest of them, right? So you don't really feel the effect. Yes, there's the network adapters in between. There are the different web application firewalls. There are the different load balancer and high availability solutions. But before we go into that, Kubernetes always comes with a container. And for people, if we're looking at, the hotel approach, or the battleship, or the containerized version, it's like, okay, these are multiple boxes on top of one big thing. So can you explain a little bit how are we taking the approach from a, yes, Kubernetes, but then container? How can people that are not familiar with this understand the value of when to hit that container node, and when you talk about the whole cluster or the whole Kubernetes?
Let's equivalent that to something from like the traditional world of infrastructure. If you take a VM, right? That VM is a workload running on ESXi. That's a node. That ESXi is being managed by vCenter, right? There's in VMware world, but it's right to any other hypervisor and virtualization platform.
Yeah,
So
any other console that will manage this at the end of the day. It doesn't really matter which one.
Basically, you have a management layer, which is the vCenter for VMs. Then you have a node, ESXi, and then you have a VM. That's the VM itself. That's the workload. If you equivalent that into Kubernetes, it's exactly the same. In Kubernetes, you have a control plane, which controls everything else. You have a worker node, which is the node itself, let's say the E6i, or in our case, it can be a VM. And then you have the container, which is basically the workload running on that node. So it's exactly the same architecture. Now, that kind of architecture, if you get like deep dive into that architecture, the difference is in Kubernetes, everything is declarable, right? I'm saying to Kubernetes, what's the intended state? That's the basic. I'm saying run 10 containers behind that service, and Kubernetes will make sure I'm going to run that. Something needs to store that state. Kubernetes needs to know what's the intended state. So for that, Kubernetes has an internal database or a key value data store named etcd, which is part of the control plane. And basically that stores the intended state. That stores the way that Kubernetes knows how to run any workload on the platform. So if you
So
think about it, yeah.
yeah, and it's, no, basically, just to clarify on this, if I'll take the the famous NGINX hotel analogy, and we'll paste it on the screen in a second for people to go back and watch it. But if I'll just cover that in a second, that kind of in a way of how the receptionist, when you come into the hotel, she checks in the system and see, hey, by the way, it's like, you're Mr. Oren Penso. Hold on, let us check. Okay, you're a gold member with us. You get the deluxe suite. Here's your key. But it's only been activated once that receptionist is actually recognizing you. So that layer of, hey, here's the information, that's how they hold it. So instead of spreading or calling who's Oren Penso, they actually see you, they verify you, they validate that, equivalent of our WAF controls, our different ways of security, and then you actually get access to this. Okay, that makes a lot of sense.
Yeah, and everything in Kubernetes is API driven and secured with those SSL certificates, with digital certificates. So every component inside that platform is communicating with each other in an encrypted way with the known source and destination for those API calls. So it's a secured platform to manage any container, right? You don't have to, when we say containers, there's also different containers, right? There's Docker, there's Rocket, there's a Containerd, there's others. But Kubernetes does exactly the same for everything. It's just orchestrating and managing that layer. Now, I have to say another thing, and I hope it's not going to be too complex for our first session and live, but Kubernetes is not just a workload management platform. Kubernetes is not just to run containers. Kubernetes is a platform to run and manage other platforms. So you can use Kubernetes to not just orchestrate and manage containers, you can use Kubernetes to orchestrate and manage VMs, right? Because a VM is a workload that runs on a node. And if that node is part of a Kubernetes cluster, you can now run not just containers, but also VMs. And there's a lot of different companies in the industry that already does that, right? There's open source project like KubeVirt, there's VMware with the Tanzu stuff, but there's a lot of companies that is aligned with that concept of one API layer, one common API layer that will allow you to orchestrate and manage workloads across any infrastructure provider. And that's the key point of Kubernetes, any infrastructure provider.
So that's actually a very good point, because you mentioned two different things here. It's one is the orchestration layer, and the other one is that one line, right? One API that is across everyone. Some people, I heard using the term, it's the Switzerland of cloud approach and all kind of different things. And this is great, but here's the spin, right? We cannot go into burpees and we cannot do pull-ups or anything like that. So we'll have a different way to spin it. If I'm a company right now, because we see two different types of companies these days, and I'm taking it to the basic level as possible, right? There are the new companies who were born into the cloud and developing everything in the cloud, and there are the more, I'll call it, and I'm being very careful here, right? I'm calling them the traditional companies that already been there for a while. Maybe some of them will, God forbid, will use the word legacy and refer to them as the legacy companies out there that used to be everything on premise, cloud is just someone else's computer, and all kind of different conversation and statement that we heard before. So if I'm thinking about it from a company perspective, how would a company actually consider the move to containers? Does this mean that I need to scratch everything and start from the beginning? Because to me, that doesn't make any sense. Or I can actually leverage and maybe do a hybrid mode or similar approach.
Well, the answer is absolutely not. You don't need to scratch anything. I'm always making the joke on mainframe. What was the best lucrative year for mainframe? Last year, right? Mainframe was here, it's still here, it will be here for the next couple of years. It's same for VMs. So what you have now is just additional layer. You have additional kind of workload that running alongside. So you can run your physical servers, your databases, your VMs, and now you can run containers on premise or off premise. Now, the main point is, yeah, go.
No, so actually, if we're still kind of on that traditional route, or because of the base of where we are and what we're doing in the field because of our industry or what have you, right? I don't need to go ahead and jump straight into the cloud. I can still live across both worlds. And some people are calling out that mainframe is here to stay. It will probably, especially because of the amount of apps that are there and are dependent on it. But go back to the previous section of our conversation when we talk about the transition from monolithic to microservices, where things are easier. But to this point, basically, what do you see on this? So if I can go both on premise and off premise, so cloud and on my environment with my bare metal, but what's next? How would you describe will be the best approach? And I know this is kind of the trickiest question, because there's not really, depends on the company, right? But what's your view from your experience being in the field for so long?
So I think that eventually customers has different needs, and they will fulfill those needs with different kinds of infrastructure and services. So there's unique capabilities for the public clouds, each and every one of them, by the way, not specific one, and that you will probably want to leverage as a customer, because I don't know, X will have the best AI, Y will have the best storage, Z will have the best, I don't know, a performance monitoring solution. There's a lot of different unique capabilities that customer will want to consume. And I think the future is exactly that common ground or common API to manage workloads on different kinds of infrastructure providers in a common way, in exactly the same way. Now, I know it's science fiction, because you can't really do that for on-premise traditional or heritage applications. And it also doesn't make sense to divide that application between on-premise and off-premise, right? But I can still see a lot of offline batches running on cloud and getting back into the on-prem as an output that you need for some kind of an application. I can give you one example that from my life as a customer. I was a customer for most of my days, and in the insurance company that I've worked on, there's a high performance computer that basically does one thing. It's just calculating the risk for you to calculate how much do you want to pay. And that HPC is working 4 times a year, and you're paying for that $1.5 million just because you need to buy that HPC. Why not taking that offline batch process and move that into the cloud, pay as you go, get that, something that is eventually a number that you're getting back. So that's just an example of something you can outsource into the cloud without affecting your current application on premise, but still use the power of cloud in a hybrid multi-cloud scenario where you have that, different kinds of things. Now, if you think about it, if you're using Kubernetes to do that on premise and off premise, you can then divide, like you can connect the dots with service mesh, and we can go into different other things. But basically, you can connect the dots between the off premise and on premise in the same process of a business application.
And I think this is exactly the point that we want to highlight here, right? It's all about the business value. A lot of the day, a lot of the movements and the hype that you see in technology usually comes from, oh yeah, there's a new tech out there, there's a new hardware, there's a new software, we're doing this. But here, actually, one of the things that you and I talked about before we did this session is, let's help people understand the real value that's behind it. And what you're articulate just now, that is the perfect business value. So when you go in and have a conversation with those board members, with the team leaders, with the different key stakeholders in your company, and you talk about, hey, this is the value of going into microservices or going into cloud, of investing actually in Kubernetes. You and I both been together on a project where we saw a customer from one of those industries that are usually going on premise. We've seen them together where they said, hey, listen, we're paying so much money for this specific service, and to your point, yeah, it runs once a year. Can we go consumption? Can we go, some kind of a subscription method, or even better, the pay as you go? Yes, for the short term, sometimes for people on a business value, it will look like, hey, but if I kept it this way, it's actually cheaper because I own this and I can play around with the numbers. But the minute that you start running it and you're actually utilizing it more than once, then it's a no-brainer, because we also need to remember that there's someone in the background that maintaining all of this infrastructure, that keeping the sanity of all the apps, that keeping his tabs on the updates to the OSs, that doing every patch, every single framework update, every single, from a DLL drop to what have you, right? Someone needs to manage it. And also, if we're bringing in the security feature to that, it's kind of, okay, so what are we doing and how are we managing this? And are we using all the same vendor? Are we using different side, different processes? So
Exactly.
that's key.
And you and me are, old enough to remember the transition to VMs, and we had a new entity to take care of, right? The new VM was something you didn't know how to handle. How do you connect that into the network? How do you secure that? How do you manage that? How do you monitor that? Everything with the transition 20 years ago to the VMs was new. And it's exactly the same thing right now. So you have a container, right? You have Kubernetes. How does it connect to your own network? How does it connect to your traditional security measures? How it's connecting into your monitoring solution and platform? How do you, there's a lot of different things to take in consideration in Kubernetes, because it's an infrastructure layer, just like VMs. It's
Yeah.
a whole world of knowledge you need to acquire, and you need to understand, and you need to take care of. And again, that's on premise. If you take that off premise in the cloud, it can be a service, but then you're locked in. And that's also something that customer needs to understand, right? If you're getting into a Kubernetes service and you need to change something, you're not managing the control plane of that service. EKS, AKS, GKE, you're not managing the control planes. You're just putting workloads on the cloud. Now, that's fine for most of the things, but if you need control, you don't have that. So there's a trade-off. As a customer, like always, there's a trade-off between different options, different clouds, and different ways of implementation of Kubernetes that you need to take in consideration even before you're doing the first step.
And you know what, this is an interesting point. You raised a few different things, right? And I want to touch just for a second on the service mesh approach, right? Because we at NGINX, and I know you guys at VMware see the same thing, right? It's about the journey, right? It's not about, okay, we need to do this. It's the journey. It's the understanding of what the customer is looking for. We always say within my team, right? We always say, okay, what's the compelling event? What are we trying to fix it? What is the biggest pain point that we have right now? And when you look into the process, you look into the microservices, you look into how you go in and transition into the service mesh, and is it needed? What exactly are we starting it? It's kind of say you should go in and start, and maybe I'm throwing in another spin here, but maybe you should just go ahead and start with an Ingress controller, right? Rather than go all in and spin up everything you ever thought about.
Definitely, by the way, service mesh is not something that you need to start with in Kubernetes. You know me, you know that I've wrote a book of service mesh for dummies. Service mesh is one of my babies for the last 5 years, 4 years, and it's definitely something that I have deep knowledge in. And I think that you raised a good point. As a customer that is new to Kubernetes, service mesh is not exactly the best starting point. Now, there's a lot of value in service mesh. Don't get me wrong. If you're a mature customer in Kubernetes and you have specific needs between like a cross-cluster connectivity or encryption or a lot of other things like canary upgrades that you need to manage with diversion of traffic and advanced inside that specific mesh and isolation level, yes, you can go into service mesh. But if not, Ingress control is definitely the starting point to just navigate the traffic inside your cluster. And that's also, by the way, for beginners of Kubernetes, that's something that they need to understand. The networking layer inside Kubernetes is not the networking layer in the VMs. And if you said, if you got into service mesh for just a single, if you're dividing that into layers, and exactly like VMs, if we had physical layer for networking, and now then we've added a software-defined network to that physical layer, now we are actually adding additional layer of service mesh or connectivity on the application layer. So that's also an abstraction or another evolution that we are seeing for networking. And again, it's going to take time until it's going to sink in
And
customers.
yeah, and you know what? I think one of the things that we're starting to see more and more these days is how the teams that were always separate, we talk about the famous DevOps versus NetOps versus SecOps, right? It's kind of almost getting to a point with Kubernetes, with the different clusters, with the service mesh, with the microservices, how everything is starting to get back to that point that all of these teams, at the end of the day, they have one goal together, and that goal is to serve the business and help the business make better choices, right? Choices that at the end of the day will maybe cost them less, but will bring bigger value or higher value when they work with their customers and so on. So I think with this whole move of all of a sudden DevOps and NetOps are working together. And when you look into the containers and into the cluster, right? How are we actually going through it? Because if I'm a DevOps guy and I'm working and I'm developing something and I'm in the Kubernetes cluster and I'm in my container, I need to work on my network segments. I need to work on my configs. I need to decide what's going in and what's going on. And I don't really have time to wait for, a ticket to be open, for change management. How do you see this? Because that's a really big thing. And I see this as a value, right?
So that's exactly the point of one platform. When you use Kubernetes to manage networking, storage, and compute under the same API layer with the same concepts and constructs, in Kubernetes you can create a Kubernetes object, which is a network policy, right? It's a Kubernetes object, but the application is on the networking and security side. You can drive that with an automation layer, with CI/CD, with automation tools directly as an API call to Kubernetes, and that I think you hit that point well when you said that shared responsibility. That's the change where you have that, DevOps, DevSecOps, DevNetOps, everything is converging into shared responsibility. Eventually, it's not just like throwing your application behind your wall into your operation team to take that code and put it in production, and that's it. And everything is getting in an automated way, or a declarative automated way, where you can actually do everything without that ticketing system in a streamline of automation from idea to production. And that's exactly the point.
And you know what? This is something that I like because we talked about monolithic, we talked about microservices, we're talking about how things been in the past, how they shifted, how they're changing, and how they're back. It's kind of a back to the future moment for us, right? Where
Yeah.
we're seeing things coming over and over again. That one layer of management, that one console to rule them all, that Switzerland approach rather than spinning up multiple products and have to manage them on your own. I think the biggest thing is probably when people hear about this, and that's something that we haven't touched yet. So maybe we'll just touch it a bit. And you just mentioned it, so I had to jump on it. It's the automation, right? There are a lot of different companies out there these days, right? That offer tools for automation like Ansible, Puppet, Chef, all kind of different things. It's mostly for containers, but can we use these tools, as you mentioned, that from a VM perspective, we can now manage the VMs in the Kubernetes cluster. Can these tools from that control plane, can they manage those VM? Can we have one automation platform to rule them all almost?
That's a great question, and it's actually a deep discussion, because you need to think about why we have those configuration applications, right? We have those configuration applications, or the automation of that configuration, to create the environment to the application to run, right? You're creating a VM which is blank, and then you want to run on that VM a Java application. You need to install everything you need from dependencies and application runtimes to run that Java, right? So that configuration or infrastructure as code or whatever is doing that middleware, that configuration of the VM or server to run that code. And what container does is taking that runtime and dependencies and the code itself and squashing that into a container image. So the first question is, do I need configuration management in containers? I don't know. But you definitely need something to create that container image, and you need something to manage the way that the container image will behave against different environments, right? Promote of the code or the infrastructure, or the container image between different environments. So I think that, and that's something that, like, it's my take, right? It's my the way that I'm thinking about it. I think that Kubernetes is actually challenging those applications of configuration management like Ansible, Puppet, and Chef, because you can do with Kubernetes a lot of those working process automation and orchestration in a controlled way, in not just in a controlled way, but something that is not just day zero, not just run script and forget about it, in a declarative, ongoing way. And that's the force of Kubernetes. So you can see Kubernetes actually doing VMs with cloud init, with post configuration of that VMs without any other configuration management or any other orchestration layer. So that's a great question moving forward about what's the future of Kubernetes and if Kubernetes will win that game as well, not just the containers landscape.
Okay, that's a very interesting approach on this, and I think these are things that we'll probably have to dwell into them more in the future. And as we're recapping everything and everything we just said, right? What would you say to a company or to a DevOps guy or to a security guy that listens to us? What will be your take on where we are with Kubernetes and microservices? And I see someone in the in our viewers actually asked the Kubernetes versus the K3s, the lightweight version, right? The binary 5. But how are you positioning this, right? What will be your suggestion to the next DevOps engineer that listens to us?
Well, first of all, Kubernetes is something you need to stop and learn. So the first suggestion will be to go open up the 1 million online webinars, materials, and courses that you can, and
But
get yourself.
but hold on. First thing, they need to start with this, right? It's that's
Yeah,
the intro for everything. Yeah, just
yeah,
to be sure, right?
that's for sure. But after this one, you need
Okay,
to expand your horizons and you need to learn more and you need to certify yourself on Kubernetes, just like you did, and again, we have that long journey in the IT, so MCSE and then something else from other companies, and you did that certification to understand Kubernetes. That's first. Second, the K3s against Kubernetes kind of thing. There's a lot of different initiatives. K3s is awesome for edge computing. By the way, edge for one customer is not edge for a different customer. Edge is something
exactly.
that is individual. There's a customer that I had a customer last week that told me that I need an edge computing solution. I have a data center of 10 servers in every location that I have.
Yeah,
That's edge for him. And it's not Raspberry Pi stuck on a pole in the middle of a junction, right? So edge is
exactly.
something different, and there's different landscape of solutions for Kubernetes for different needs. So nothing wrong with K3s for the specific needs. Um, Going back to Kubernetes as Kubernetes, learn, educate yourself, and start small. Start with something that like a quick win. Take one application that you have, a stateless application, front end, easy, Node.js, something that you can start with, containerize that with a container image solution of whatever you want, and then run that on one Kubernetes cluster, understand what's going on, and then expand and extend. Because you need to understand, again, you don't know what you don't know. And until
Yeah.
until you get to a point where you're running a workload on Kubernetes, you don't really know how challenging it is to manage the networking, the security, the monitoring, the exposure of that application with ingress or something else. And so start small and expand.
And I think that brings us to a great ending to our session where we're basically saying this is a journey, guys, right? It's not a sprint like we always say. It's not a sprint. It's probably a marathon or an Ironman or a never-ending WOD. In that, going back to our CrossFit terms, right? It's something that you're evolving also as you go, right? You're learning more. It's like, okay, we can do this, and when we go uphill, we need to challenge this in a different way, or maybe we need to phase the problem in a different way. It's a journey. We need to start from something. The best way to be is to find that compelling event, to find that pain point that we need to fix right now, get the teams behind us from a perspective of driving a team together with the customer and the product, regardless to the product that it will be, right? And jump together, take the challenge, see how it goes. I know that from our perspective, your perspective, right? It's all great. We dropped the link to the hotel video. We also have a link. Oren, I know that you provided some information into that also from a Cube Academy. There is your book that you'll share the link also, so people can understand a bit more in service mesh. We had a few more NGINX stories around service mesh. So there's a lot of good content out there. We're always going to be here, right? So if people have some more questions, they can always reach out to us, and we'll be more than happy to follow up and support this. Owen, any closing comments from your side?
No, as you said, it's a journey. So yeah, get started.
Yeah, it's been a pleasure to have to have you as a companion for the journey. I appreciate your support and help, and thank you. We'll probably have another one of those in the near future. So thank you very much, all. Thank you for listening to us. This has been an EMOM, basically, or a never-ending EMOM of containers, Kubernetes, clusters, service mesh, and what do we do around that. If you have any more questions, please feel free to hit us up on the different social channels. Thank you very much, all. Have a great rest of the day, and we'll talk to you soon. Thank you. Owen, thank you very much, my friend. See you soon.
Thanks, everybody. Cheers. Bye bye.
Cheers. Bye-bye.